We are a group, I'm not alone. A lot of work is done by all the collaborators. Here you can see. I divided the speech in two main parts, the pre-PPILOW state and post-PPILOW state, like an era. As you know, all the surveys done in Europe underline the relevance of free-range condition of local feeds and happy animals in terms of citizens. So, as you know, the amount of slow-growing production in Europe is increasing for 2 or 3% every year. It's very important in some countries, in others less, but anyway, it's a general trend. When you speak of free range and organic, we have to keep in mind that we have, generally speaking, in terms of efficiency of resource utilization, we have high energy expenditure due to higher kinetic activity of animals, higher investment for thermoregulation, high investment for immune response. This means that you have less feed efficiency. It's clear. There is no do. Less feed efficiency means, in monogastric animal, high need of land to produce crop and so on. So at the end, we have the need to rethink to this system, because otherwise it's not sustainable. And the need, the most important topic of this rethinking are mainly a combination of agroforestry, a combination in one area of animals, crop and trees, and the development of low input diets. What means low input diets? We have to formulate diets not with the same mind that we use in commercial system. We have to change the use of soybean. We have to reduce other crops, for example, maize. So it's possible, in general terms, we try to make some little experiment, even with slow-growing strain, to reduce the environmental impact by changing all the formulation, so all the crop that you use inside. For example, if you use local crops like fava bean, for example, and you use 20% in comparison with soya bean, you reduce a lot the water amount that you use during the agricultural phase. But anyway, it's an interesting procedure, but we are not interested now. What is agroforestry system? We have a lot of experience, not a lot, but an experience of the use of animals in pasture. We use mainly chicken, but even goose and so on. And we use 2 or 3 ways combination. One is mainly focused on olive trees. You have seen a lot of olive trees here. Olive trees is an activity that produces losses in terms of money. And so it's very important to increase the economic revenue of this activity. On the right side, you can see a goose in the vineyard, and in the last part, you can see wild asparagus. So we have tried to make 3-way combination. So olive trees, wild asparagus, and chicken. Here you can see some example with trees or bushes or something that are very important for chicken, because chicken is not interested in going around in a natural pasture, but it ranges a lot when it's covered by trees or bushes or something else. Okay, here there is a general review on the many interactive effect regarding the use of chicken with all the crops and grass and so on. There are positive and negative ones, but there are a lot of this interaction. Anyway, if we try to define the main effect, we can divide two main aspects. One, the effect of this agroforestry on the animal welfare and on the products, so meat and eggs. Another one that is really very important one is the effect on the agrosystem. The main effects are environmental impact. We reduce the land use because in the same area we have plus than one production. We reduce fertilization and weeding. So 1,000 chickens fertilizate, for example, is enough for the olive trees and even for grape. So you don't add any chemical fertilizer, only manure. You have an effect on the site structure and you have an effect on the production of crop and trees. Just very fast. We produce some papers on the combination, the effect on LCA and so on. And here you can see that we reduce the land use, making in the same area two types of production or three types of production. The environmental impact is reduced. We have a sometimes positive effect even on the site structure, but it depends mainly on the density. It's very important to define the density of animal, because when you have high density, sometimes you can have damages to the soil structure. But anyway, when you are, for example, here we compare, I don't remember very well, but a control area with 100 Gs per hectare and 200 Gs. So here you can see that the low density is much better. The microbial community works more in this soil. The biomass is much more efficient in working with the mineral and in production of CO2. So mainly depending on density, it's possible to have a positive effect even on the soil structure. There are other aspects. For example, here we have measured the effect of combination on the production of grape. And so naturally, if you have grape and nitrogen and other minerals, you can increase when you use good density, even the grape production. You can control even some disease, because as you know, the chickens pick up insect. So here, for example, it's very diffused, the oil fly. And so if you have a lot of chicken, here you can see an olive stone. Same. So it's possible to reduce, in some case, even some problem relating to the disease of plants. But we are interested mainly in chicken. So what happens when you put bush or olive trees in a field? Here you can see that the distance from the house, from the poultry house, increase in this chicken when they have olive trees or bush. So generally speaking, they use most the outdoor when the outdoor is reached mainly with trees. It's the same with the goose. So when you have orchard or grape and so on, the geese are interested in in ranging more. Here you can see only few chickens, seems few. There are more than 1,000, so all the chicken is inside the bush. So it's very important for the chicken to have something where stay. Just a preliminary conclusion. So the enrichment improves the use of pasture. It's very clear. Not only in terms of grass intake, but even in terms of use. So if you put trees, the chicken goes far from the house. Trees should be better than bush, it's clear. But the magnitude depends by genetic strain. So some genetic strains are more active, more interested in ranging the outdoor. Some words on the meat quality. As you know, there is a complex interaction between polyunsaturated fatty acid, vitamins, activity, and so on. It's a complex mechanism, so we are not interested to focus on it. But you know, and we know that it's very complex. Generally speaking, when you compare, for example, fast growing, medium growing, or slow growing, and you analyze, for example, in the meat, in drumstick and breast, and the same, the content of the main vitamin that counteract the oxidation of polyunsaturated fatty acid. For example, here we measure alpha tocopherol. So there is a linear trend. So when you use more the grass, when you use more the outdoor, you have a lot of alpha tocopherol. One very important thing to underline is that we need grass. So if you put chicken in a tennis court, they don't eat grass, it's clear. And so the alpha tocopherol don't increase, and PUFA and so on. So the grass intake is very important, and the grass is very important. Here we can see the comparison in geese of alpha tocopherol, and you can see that when you put trees, the alpha tocopherols increase. So animals eat grass. But there is a strange interaction. So if you eat more antioxidant, why the oxidation is so high or higher? Because of the movement. So kinetic activity has two phases. One is positive, so foraging behavior. They intake a lot of bioactive compounds. But on the other side, we have seen before, they produce a lot of radicals. So the training, the genetic strain and so on are very important to define this balance. And so we have to find a fine balance, a fine tuning of an intake and activity production of ROS. Another very important aspect is the entry fatty acid. When we compare in terms of percentage of fatty acid, a fast-growing strain outdoor in organic system with a slow-growing one, it's possible, it's very easy to find big difference, so 4 or 5 times more in terms of percentage. But the problem is that slow-growing are very lean. Fast-growing are not so lean. So when you compare in terms of milligram, it's not so evident. But anyway, it's a fact. The reason why is that we make a lot of studies on that. So it seems that local breeds or very slow-growing breeds have a high efficiency in utilize alpha-linolenic acid and in making long-chain production. So here you can see, for example, that when you give to animals flaxseed, slow growing are very interested in evolving such fatty acid that produce long chain PUFA. So there are metabolic difference, very, very huge metabolic difference. Okay. As a take-home message, take-home message, kinetic activity and foraging behavior are linked, it's clear. More foraging means more adaptation. Behavior affects the intake, but on the same time affect even the production of radicals. So the interaction PUFA, radicals, and antioxidants, it's really very important. We are very focused in this moment to analyze this interaction. So, PPILOW results, and PPILOW one, not PILOW, because we have two P. So PPILOW means a lot, evoke a lot of things, more physiological, as you know. Anyway, I make two main points: foraging behavior, body storage, grass intake in different poultry strain, and another aspect that is related to the methods for behavior evaluation. That is another important aspect, because to make behavior observation, making behavior observation is very long, it's very boring, it's time consuming, but anyway. Grass intake, you know, when you have different daily weight gain, so different weight at the end, generally speaking, the heavy chicken intake less grass, and it's very clear. When you compare, for example, what is the pattern of this grass intake determined in the blood, and this is blood, yeah. In the blood, you can see that, for example, regarding the entry, only the birds that intake a lot of grass intake a lot of entry. For the other one, on the right, the intake of entry coming from the grass is nothing. On the contrary, when you look, not on the contrary, but more, they take more, the intake of alpha tocopherol, it's very important when for animals. So when animals are able to intake a lot of grass, they intake a lot of alpha tocopherol. Bioactive, what is?
N6 carotenes.
Okay. Okay, N6. N6 comes directly all from the diet, from the feed, sorry. Carotenes, even when you have a low intake, low active animals, the intake of carotenoids mainly comes from grass. So the grass intake is very important in terms of bioactive compounds, mainly for active animals. But, okay, grass intake is linearly correlated with entry intakes. So when you change the strain and the forage behavior change, you have a linear correlation of intake of grass and intake of entry. That is really very important. But we are not interested only in seeing what happened to the animals, to the entry intake. We are interested in seeing what happened to the meat. And what happened to the meat is really amazing and strange and not expected. So when animals intake more, so animals that have high foraging behavior have even a negative correlation with the storage ability. So they use this entry for energetic reason. So in other times we underline that it's very important to try to find an equilibrium between intake and storage ability, because we are interested in eating LCN3. not only having animals in good welfare and so on. Okay, so this is very important. So probably we have to find an equilibrium here, probably, where we have high intake forage, high intake inventory, but even a good storage ability. Otherwise, they are wholly for birds, not for human. So the reason why is that local strain or very slow growing strain regarding the fat destiny, they make mainly recycle and turnover this fatty acid, and they use this fatty acid for their activity. On the contrary, fast growing use this fatty acid for storage and structure, so they are less able to elongate and desaturate fatty acid, but they store a lot, and so they produce low quantity of N3, but they store all the quantity. Okay, I finished. No, we are trying to define an equilibrium between these different things with a model, with a model. So we try to make a sort of find a sort of indication from a very complex model that put in correlation kinetic activity, energy metabolism, foraging behavior, and so on, to define at the end the body structure and the meat quality. Probably we will produce this type of general model at the end of PPILOW project. So we are able to put all this huge amount of variables inside. Anyway, regarding the second aspect, the trying to find a solution for reducing the time need to assess the behavior of animals. So it's clear that the golden standard is the continuous recording of the behavior, but in outdoor conditions it's quite impossible because we have a lot of animals in different places, and so it's not possible to define with this technique. So in this paper we will try to define the relation between scan sampling at different time intervals to define what is the best one with a reducing time to reach these results. And so when, for example, we compare low occurrence with medium and high occurrence how do you say, behavior. So high occurrence is, for example, kinetic activity. Low occurrence are attacks or interaction between animals. So when you look for high occurrence categories, high occurrence category, there are no difference between these three different. So when we are interested to big behavior categories, it's possible to make scan sampling very not so time consuming. But when we are interested in low or in medium, probably we have to define a very short period. Okay, so here you can see that when the occurrence is very high, the difference between the methods are very low here, but when the occurrence is very low, the difference are very high. So it's the reason why, if you are interested in a specific very low occurrence behavior, you have to define a 5 minutes or 10 minutes observation. Okay, I finished. Here you have all the reference, if you are interested. Okay, thank you.
Thanks for the presentation. I was curious with the grass, the chickens eating grass. What I hear a lot in the Netherlands from veterinarians, we also have chickens on grass, is that they're like, yeah, it's not really possible because it's, I'm not sure how you say it, but they cannot process it really well, and there's a lot of problems with that. So I was curious what your experience is.
So, for sure, for chicken, grass is not a way to gain energy or protein and so on. But from the point of view of bioactive compounds, it's very useful. So it's sure that chickens don't use grass for increasing growth rate and so on. For goose, it's different. With the goose, we have 80% of requirements that are directly given from grass, so it's really a very interesting aspect. But anyway, in chicken, it's only a way to have higher welfare and high intake of bioactive compounds, so polyunsaturated fatty acid, mainly alpha-linolenic acid, alpha-tocopherol, carotenes, and so on.
Sorry, and there's not a lot of problems being seen with like the grass being stuck in like the.
We never observed.
First, thanks for your presentation. Based on your experience, what is the correct age of grass in order to promote a correct usage of the pasture?
I have no precise data on this, but generally speaking, chicken prefer to eat grass, fresh grass, not very tall, not lignified, and so I have no specific data on that, but generally speaking, they prefer grass not so developed and at the very early stage of growing.
Okay.
But there is a lot of things to know regarding the type of grass. There are a huge room to.
Thank you for the presentation. It was very interesting. Some results about, for example, the alpha-tocopherol content. You had a higher alpha-tocopherol content in the induced broilers or animals with pasture, and also you had a higher MDA content. So I was wondering what happened with the shelf life of that meat. You decrease the shelf life?
For sure.
Or?
For sure. So the shelf life of an organic product, generally speaking, is shorter than a commercial one. So another aspect related to this problem is that probably we have to rethink to the feed of this animal, of this free-ranging or so active animals. Probably we have to increase, for example, the level of antioxidant, because probably the amount coming from grass, and in some case there is no grass in some season or in some condition, because we are speaking of experimental condition mainly, but when we have 3,000, 5,000, generally there is no grass. And for example, in laying hens, it's very common to have no grass. So laying hens are playing tennis. It's the same. So no grass, only red land, and so. And probably we have to add some other antioxidant directly in the feed. So the formulation of these animals should be different from the commercial one.
I was wondering if you have any information on the cost savings from feed you can get by providing more pasture to the animals, because feed is a big cost.
Generally, you have no cost saving because they intake, for example, 15% of dry matter coming from, but you don't have any effect on the productive performance. So the grass don't determine any increase or any energy or plus in energy or something in protein, but it's not sure.